So far, we've been looking at the role of signals in simply terminating processes. But it gets much more interesting when you respond to the signals by writing a signal handler. Now, the business of actually installing the handler, that is, associating the handler with the signal, is most easily accomplished with the signal system call. The first argument is the signal number you're installing the handler for, and the second is a pointer to the handler function. Now in C, if you write the name of a function without calling it, as we do here, you get a pointer to the function. Just as if you write the name of an array without indexing into it, you get a pointer to the array. There are two special values, sig-ignore, which means we want to ignore the signal, which is very common, and sig-duffle, which we use to restore the default handling of the signal. The return value from signal is a pointer to the previous handler in case you need to restore it later. Now there are a few problems with this call and a better alternative, as we'll see later, but it will do for now. Let me talk you through the sequence of events when a signal is handled. To start with, we nominate a handler for the signal, in this case sigint. We then go about our business and the signal is delivered. At that point, control is immediately transferred into the signal handler and the handler executes. When the handler returns, the flow of control continues in the main program. Now, although this is only a sketch of the code, one detail I have got right is the signature of the signal handler. It receives an integer argument, the signal number, and returns void. Be aware that in general, signal delivery is entirely asynchronous with whatever the program happens to be doing. It can occur at any point. And we'll see later how you can block signals from delivery during sections of code where you don't want to be interrupted. Now, one complication is that some blocking system calls, such as reading on an empty pipe or on an inactive network connection, will get interrupted if a signal occurs. So here we have a program that performs a blocking read of some sort. Meanwhile, a signal arrives, and the read will immediately return, apparently with an error, but with an errno value of EINTR, meaning interrupted system call. If this happens, you'll usually want to try the read again. Typically, this means that you need to wrap the read call into a loop, something like the one that I've shown here. Now here's a really simple program that establishes a signal handler. Here is the handler function itself. Notice it takes an integer argument, the signal number, and it returns void. All it does is it prints out a message to say which signal it received, and it sets a counter n to 0. In the main function, we establish this handler as the handler for sigint signals, and then we just spin round in a simple loop, printing out the counter and sleeping for 1 second each time round the loop. So we'll save that and we'll build it. And then we'll run it. And here we are spinning round the loop, printing out the value of the counter. Now I can easily send a sigint by typing my interrupt character, which is Control-C. So here we go. And you'll see that the handler is printing out the message and the counter has been reset to 0. I know you can't see what I'm typing, but trust me, I've typed a Control-C. Let me do another one, try it again. And again, the counter has been reset. Now, it's fairly easy to terminate this program. If I type Control \, then we get a sig quit signal, and the program is terminated by that signal, and also a core dump is generated. Let's run it again. And this time we'll hop over to another terminal window get the process ID of the program, and we will send it a SIGINT signal to which it responds in the way it did before when I just sent it using a Control-C on the terminal. If I send it, for example, a SIGTERM signal, then because the program isn't catching that or ignoring it, that will cause the program to be terminated. Now let's go back to the source code and we will ignore a couple of signals. We'll ignore SIGQUIT, that's the one I generate from the terminal with Control \. And we'll ignore SIGTERM. So we'll save that. In the window on the left, we'll rebuild it. And we'll run it again. Now if I press Control-C here, then the SIGINT thing is still working, of course, it's resetting the counter. If I do a Control \, here, then nothing happens. I'll try it once more, still nothing happens. We are generating a SIGQUIT, but it's being ignored. Similarly, if I come over to this other window and I get the process ID as I did before, and I send it a SIGTERM signal, then this time nothing happens because I'm also choosing to ignore SIGTERM signals. Now I have one way I can absolutely guarantee to kill it, because the signal number 9, SIGKILL, can't be caught, it can't be ignored. So we'll send a signal number 9, and if you look over in the window on the left, the program has indeed now been killed.